When we say something static, all we mean is that it belongs to the class itself. So you can see here, class.method, we are on the class, we're calling the method, that means it is a static method. So if something is non-static, instead of being on the class itself, it is on an instance of the class, which means we would have to do something like this, new class, to create an instance of the class, in this case called C, and then we can call the method on the instance. So the main difference here, if you look at the top call, we're on the class itself, that is a static method. If it is static, it exists on the class. And on the bottom call, we are on an instance of the class. So that's a non-static method. Non-static instance, static class. So that's the simple explanation, but I know this can be kind of odd to wrap your head around at first, at least it was for me. So let's take a look at a real example, something you've probably used that takes advantage of static methods. And after that, we'll look into how we can add static methods to our own classes. And just as importantly, when we should and should not do this. First though, a better example of a static method, and I want to start with this character class. So if we wanted to create a new instance of the character class, we could do something like this, character C equals new character C. But we have some red squigglies. This is not ideal. And it looks like we're not intended to use the constructor in this manner. Instead, it suggests we use a static factory value of. Now you'll notice that static is in the definition there. That's a bit of foreshadowing. We will get into that in the near future. But first, let's just take this advice. Instead of using the constructor, let's say character.value of and then pass in C. We have a warning. We can ignore that for this example though. Now we have an instance of the character C. Now that we have this instance, we can do some stuff with it. Let's make a Boolean called isB and set it equal to C equals B. If we print the result of this call, we can gain the incredible insight that the character C is in fact not equal to the character B. The power of technology is amazing, I know, but the result of this call is not really what I want you to pay attention to here. Instead, look at the difference in how we call the two methods we are currently using. When we call value of, we do so on the character class itself. So that's not an instance, that's capital C character dot value of. Whereas when we call the equals method, we're doing so on the instance that we created. So be sure you understand that difference. Character.valueof is a method being called on the class itself. C.equals is a method being called on the instance. And this is not a matter of preference. If we change the way we call these methods, you'll see it doesn't work out. So instead of character.valueof, let's try C.valueof. And we don't even have to pass a parameter. We'll immediately get a warning, static member value of accessed via instance reference. What does this mean? Well, remember, we said static belongs to the class, whereas non-static belongs to the instance. So let's read this message with that in mind. Static member value of. So if something is static, then it belongs to the class. It's saying value of belongs to the class. And the problem is that it's accessed via instance reference. So we're taking something, in this case, a method that is a static member, it belongs to the class, and we're accessing it via an instance, via the object we created. That is not how this is supposed to work. If something is static, it belongs to the class, and therefore it should be called from the class in the way we originally did. Now, in the same way, if we instead type in character, the class, and try to call the equals method from that, we get another error. Non-static method equals cannot be referenced from a static context. So again, let's think this through. Non-static method, so a method that belongs to an instance of a class, not the class itself, cannot be referenced from a static context. So what's a static context? Well, we just said that if something is static, it belongs to the class. So a static context is the class. It's saying, hey, you're in a static context here. You are on the class itself, but you're trying to access a non-static method, equals. Maybe you don't believe me that this method is static or this method is not static. If that's the case, then first off, that's wild. But second, we can jump into these classes and see the definition. So if I hold control and I click on value of, you can see we've jumped into the character class and we're at the definition of the value of method. So this is a static method. And a static method belongs to the class. On the other hand, if we again hold control and click on equals, we'll jump again into the character class and this time to the definition of the equals method. In this case, it's just a public Boolean equals. There's no mention of static because non-static is the default. So if you don't explicitly say something is static, it's non-static. You don't have to say non-static or something like that. Hopefully that clears up what we mean when we say something is static or we say something is non-static. But what about when you're building your own classes? How can you know when to make something static, whether it's a method or a variable, and when to make something non-static? What should the thought process be when making that sort of decision? Well, let's take a closer look. Let's say we've been hired to build an e-commerce program, obviously the first thing we need to do is create the product class. So making a class is simple enough. New Java class, we're going to call it product. What is the first thing a product needs? Of course, it needs a name. So let's just make that a public string for the sake of this example, and then stop and ask ourselves, should this variable be static or non-static? Well, let's think it through. Remember, static belongs to the class, non-static belongs to the individual instances that we make from the class. So should something like a name belong to the instance or the class? Well, let's think about what it looks like to make an instance of this class. So we will say product, maybe shoes, equals new product. And then if we wanted to make another one, we could instead call this pants. And if we wanted to make another product, we could instead call this one, let's say, hat. So now we have 3 products, each an instance of the product class. So let's say I did something like shoes.name, and then down here I did pants.name. Would I expect to get something different from each of these calls? If so, that means it's determined per instance, which means it needs to be set at the instance level, which means it needs to be non-static. On the other hand, if I expected to get the same result no matter what instance I was calling from, it might be a better idea to assign this at the class level as a static variable. So in this case, we're going to want a different name depending on what instance of the product we're at. Shoes and pants should not have the same name. Pants and hat should not have the same name. This needs to be determined at the instance level, so it needs to be non-static. So this definition is perfect the way it is. We do need a way to set the name. We can go ahead and do that through the constructor. So we can take in the name as a parameter of the constructor and then say this.name equals name. What this is referring to, if you didn't know, is this instance that we're in. So when we call this within shoes, we're referring to the shoes. But when we call this within pants, we're referring to the pants. It is whatever instance you are currently within, which is perfect because we want to take this name that's provided through the constructor and assign it to the particular instance's name variable. So it's going to yell at us now because we're not providing this name parameter. We can go ahead and fill this in. The shoes can be Nikes, the pants can be Levi's, and the hat can be a nice hat. The only kind of hat I wear, if we're being totally honest. Now let's go ahead and print this out so we can see what we're working with here. Let's run this and see. Perfect. We have Nikes, Levi's, and a nice hat. So we've done it. We have a product, but our boss, of course, has another requirement for us. Boss is saying not only do we need a name, we need an ID, and it needs to be a unique ID assigned depending on the order that the products are created. So what does that mean? It means if we create shoes first, it should have an ID of 1. If we create pants next, it should have an ID of 2. And if we create hat next, it should have an ID of 3. Depending on the order they are created, we need to assign the ID. How can we do this? Let's step back into the product class and think about this. Let's take a big problem, break it down into smaller problems. So the first smaller problem is that we don't have an ID at all. Let's go ahead and fix that by making a public int ID. It can be an int because we know it's just going to be 1, 2, 3, 4, etc. But now we're adding a new variable, which brings us back to the question, should this variable be static or non-static? Let's think this through again. Just like name, does ID need to be assigned at the class level or the instance level? Well, we said for the name that when we ask different instances for their name, we're going to expect something different. So it needs to be assigned at the instance level. It needs to be non-static. Doesn't this logic also carry over to ID? If we ask 2 instances for ID and we get the same result, that's bad. That's the whole point of an ID, to identify the instance. So this needs to be assigned at the instance level as well, which means it needs to be non-static. So we're good. Public int ID, we're done. But we're not exactly done because we do need to assign something to this ID, and it can't just be a random number. Remember, our requirement sent to us from our boss is to assign this depending on the order that the products are created. So we need to somehow keep track of how many products have been created so we can assign the ID correctly. So there's a few approaches we could take here, but for the sake of this example, let's create a new variable, an integer, and call it total products count. With this variable, we can keep track of how many products have been created and then assign the ID with that information. So total products created initially has to be 0, of course. We know that each time we create a new product, we're going to be calling this product constructor. That's how we're making the products. So we can take this variable and increase it by 1 each time the constructor is called. And now that we have that information tracked, we can set the ID to the total products count. Is this going to work? Well, when we create our first product, the total products count is going to be 0. We haven't touched it yet. We call the constructor to create the product, it sets the name, and then it increases total products count by 1. So it's now 1. Then it sets the ID to 1. Our first product has an ID of 1. After that, we create another product by calling the constructor again. It sets the name, of course, and then total products count is again increased by 1, from 1 to 2. Then the ID is set to total products count, which we just said is 2, so the product ID is 2. This seems like it's going to work. Instead of logging the name here, let's change this to log the ID and then run the program. And unfortunately, we have an issue. It should be printing 1, 2, and 3. That's what we would expect the IDs to be if we're creating 3 products. Instead, we have 1, 1, 1. What it looks like is that total products count is being reset to 0 each time we call the constructor. So instead of it going up 1, 2, and 3, it gets reset to 0, goes up to 1, sets the ID to 1, and then the next time we call it, it's again set to 0. This is happening because we forgot to ask a very important question. Should this variable that we created, total products count, be static or non-static? Just like we did with name and ID, let's think this through. If we have 2 different instances and we ask each of them for the total products count, do we expect a different result from each or the same result? Remember, with name and ID, we expected a different result from each, so it had to be set on the instance level, so it had to be non-static. But in this case, total products count should be the same no matter what instance we're asking. Once we've created these products, it shouldn't matter if we're on shoes and we ask for the total product count, or if we're on pants and we ask for the total product count. Each of these should be returning 3 because we've created 3 total products. So this doesn't need to be set at the instance level. It has to be set at the class level. It has to be static. And now that we've thought that through, what's happening here makes sense. This total products count lives on the instance level. So on each instance, it's getting set to 0 and then increased to 1. We're not able to keep track of this progress from one instance to another because the variable is non-static, therefore contained to each individual instance. When we make shoes, yes, it increases to 1, but when we then step over to make pants next, pants has no idea that total products count has increased from 0 to 1 because total products count lives on the instance level. And if you look at the warning that the IDE is giving us on total products count, it's kind of telling us we're making a mistake here. Field can be converted to a local variable. What's it mean by this? Well, let's take the advice. What it was saying is because this is not static and it's being set to 0 at the beginning, it would be more clear what's going on here if you move it into the constructor, because that's what's happening. This lives in an individual instance. So to put it outside of the constructor and make it look like it might live outside of the instance is misleading. It would be better here as a local variable. But of course, that's not what we actually want. What we actually want is for this not to just be a private int or a local variable. We need it to be a private static integer. This is going to give us a new warning though. Static member product total products count accessed via instance reference. Well, we know what this means now. Static member, it's saying, hey, this lives on a class level, is being accessed via an instance. So we're in a non-static context. We are in the instance itself, and we're trying to access something that is in a static context. It lives on the class. In this case, the problem is that we're using the this keyword. Remember, what this is referring to is the current instance. So again, when we're in shoes, this refers to the shoes. In pants, this refers to the pants. It's referring to the instance. That's great when we're setting a name that needs to be set on the instance itself, and it's perfect when we're setting an ID because each instance needs its own ID. But when we're setting the total products count, this doesn't live on the instance, it lives on the class, and we can tell because we've made it static. So what happens if we take the advice and correct this in the way it's suggesting? It removes this because we don't have to worry about this. We don't have to worry about the instance that we're currently on. This is static. We're operating on a class level now, not an instance level. So let's save this and run the program again. And now it's perfect. 1, 2, 3, the IDs are set in the order that they should be set in, and it's able to track this total products count when it sets the ID because we've made it belong to the class as opposed to the instance. I hope you feel a bit more confident now about what static means, what non-static means, when you should be using static variables or methods versus non-static variables and methods. If you'd like to dive deeper and learn what that static factory we touched on earlier is, click the link in the description or on the video now. If you enjoy my teaching style and would like to see my most in-depth material, go to studied.dev. Thank you for watching.